Okay, this is A.REI.6, Algebra, Reasoning with Equations and Inequalities Standard 6, Video 1, Solving Linear Systems by Graphing. Here are a few terms I'd like you to write down in your journals and define. All right, we have a picture of a coordinate plane here, and it says to check the intersection points. So what we have here are two equations. We have two linear equations, graphed in purple and red, and we are noticing that these lines are intersecting at a point that we call the possible solution of the system. Now, a system means more than one. So we have, in this case, two. Sometimes you might have 3 or 4 different lines, and wherever the intersection point of these lines are, this is a possible solution. And that means that the ordered pair x and y will satisfy both of the original equations that we had before we graphed them. So let's find out what the intersection point is first. And we go from the origin, 1, 2, 3 for the x, and then 1, 2 for the y. So it says the ordered pair solution might be 3 and 2. Now, how do we check that? We check that by substituting in our possible point to the two equations. And if the two equations both work, which means they both equal each other, then we should have our solution. Let's see how this looks. Substituting in my x value, which was 3 in the ordered pair. So we have 3 added to 2 times the y value. The y value was 2. And that should be equal to 7. So if we have the correct ordered pair, what I talked about just a few seconds ago, if they are equal to each other, that means the left side is equal to the right side. So here we go, order of operations, multiply first, so we have 3 added to 4, and this one checks. So this is satisfying the idea that the ordered pair of 3, 2 will work in this equation. Now, in order for it to be a solution, that same ordered pair 3, 2 must work in the second equation. So they are working simultaneously. Substitute in our values. Our x is a 3, so 3 times 3 minus 2 times our y value. Now, it should equal 5 if we did everything correctly here. So 9 subtracted by 4, and it looks like this one also checks out. Okay, so final answer would be the intersection point of 3, 2 is the solution of the system of equations. Okay, next example. Now it's our turn to find out what these two equations of the line look like on a grid. Notice the intersection point, and then find out if the intersection point would work in both equations. So that would be called the solution again. But before we do any graphing, we know that we need to put it in some type of form to graph on a grid, and we are very familiar with the slope-intercept form. So let's take a little bit of time and take each of these equations and put them into slope-intercept form. Okay, so let's rearrange this. All right, stabilize the y. Take this negative x term to the right. If we take the term to the right, we change the sign. It was negative, it becomes positive, and then we kept the negative 7 on the right. Second equation, stabilize the y term. Take this x over to the right. It becomes negative x. Keep the negative 8. We didn't move it. Divide both sides by your coefficient of 4. Everybody gets divided by 4. So we have y equaling negative 1/4 x minus 2. Now the reason we have a 1 is because the coefficient in front of the x is invisible, so this is a -1. So we have the fraction or the slope of being -1/4. So now we have to take out our graph paper. We're going to graph equation 1. We'll do that in pink. So that's y equals x minus 7. Let's go to the y-intercept of -7, 0, -1, 2, 3, 4, 5, 6, 7. That is our b. That's our y-intercept. And then the slope of the line, we know right here, the slope of the line is the coefficient of the x. So my m is equal to 1. As a fraction, we could have 1/1. So from our b, we go rise 1, run 1, rise, run, and you could keep going on. Let me get a line out of here for you. We'll get rid of all those markings. So let's go pink. Okay. Looks good. Maybe extend it here. Okay. So there's the equation of our first line. Let's label that. It was called -x plus y equals -7. So I'll just come up here. -x plus y is equal to -7. There's line 1. Let's go find line 2 now. Line 2 says y is equal to -1/4 x minus 2. We'll do that in red. So let's go to our b term, our y-intercept. Starts at -2. And the slope was, I believe, -1/4. So we start at our b and we go, let's go down 1 and right 4. Down 1, right 4. And we can get one more, I think. Let's make sure. Okay. Get out the red line. Run it through. Okay, looks like we have a intersection point here. And let's label that. So the intersection point of our two lines is the possible solution. And that solution is the ordered pair called 1, 2, 3, 4, -3. Now what they're saying is that that ordered pair of 4, -3 is the solution to the system of equations. Now it looks like I lost my labeling. I'll label the lines at the end here. Let's go check out 4, -3 first. Okay, let's check the solution. Substitute in the values. My x value was 4, so I have negative my x value. Stabilize the y. Add the 4 to the other side, so -7 plus my 4 is -3. Okay, and then the one on the right, let's see, x is 4 plus, okay, so we have 4 minus 12 is equal to -8, so we have -8 equaling -8. And let's see, let's go back in that first one. I wanted to show that the problem, I guess we could just do it right here. If I know that y is -3, I would take that and substitute it in right there. So we have -4 plus -3, and that should check out to be the -7, and it does. Okay, so our solution does check out to be 4, -3. I want to clean up one thing. I like when we label the lines after we graph them. So the pink line right here says negative x plus y equals negative 7. And then the red line we will label as x plus 4y equals negative 8. It's just a good habit to get into here. Negative x plus 4y equals negative 8. Double check there. Oh, it was positive x plus 4y. Positive x plus 4y equals negative 8. All right. In your journal, I'd like you to define the given terms on page 2 of the flip chart. Write down a few sentences on what you have learned from this video. If you have any questions, make sure you also write those down, bring those to class. There are going to be many more methods of solving simultaneous equations. Sometimes we call them systems of equations, different methods. Um, Ultimately, they all come out to have the same answer. Those are going to be coming in the future videos, and we are definitely going to be applying these to the word problems, some real-world application problems, and we will take care of that in class.